Hey everybody, this is going to be our last video for Unit 8. And we're finally getting to rational equations. We're only going to have 3 examples. This video will be a lot quicker than the last. So our goal here is simplify each side. So if there were like multiple rational expressions, adding, subtracting, we want to get those added and subtracted before we actually start solving. Okay, and one of our main strategies here is to cross multiply. We really just have a proportion equation, and this is where you would cross multiply. That's where you've seen it in the past. The other thing is we're going to have to make sure that we're checking for extraneous solutions. Remember, the denominator cannot equal 0. So if I plug in some solution that I find and it makes one of my denominators 0, it's extraneous, we'll toss it out. Okay. So our first one here, set up, ready to go. We have a rational expression equal to a rational expression. We're going to cross multiply. So we're going to multiply the 7 and the x together, and that's going to be equal to the product of 4 times x minus 6. So we'll distribute. We'll subtract our 4x. We'll divide by 3. And there we have it. So this is a nice, easy one to get us started here. And we can see when we plug this x value back in, we are not going to get zeros in our denominators, so it's good. Okay, this one, same kind of strategy, right? We've got a rational expression equal to a rational expression. There's no adding or subtracting with the expressions I need to do, so we can just jump to cross multiplying. I'm going to take the product of m plus 3 and m minus 2, and that's going to be equal to the product of 3 and 8. So with this one, let's multiply these binomials together. We get m squared minus 2m plus 3m minus 6 equal to 24. Let's combine these together. Let's bring that 24 over. So we get m squared plus m minus 30 equal to 0. Okay, and the reason that I wanted to get everything to one side was it's quadratic. I need to get everything to one side before I can factor. I need that quadratic trinomial here to be equal to 0 before I can use my factoring method. So let's factor here. Okay, it would factor into m plus 6 times m minus 5, which is going to give us solutions of negative 6 and positive 5. Remember, the curly brackets just show that it's a solution set. There is more than one solution. And if we do a quick check, we can see that if we plug in our solutions into our denominator here, neither one of those is going to give us 0. So both solutions are good. So I want to show you one more, and I want to utilize a slightly different strategy. Okay, and if you recognize this as you're solving, you're welcome to use it. Okay, cross multiplying will still work here, but there is a slightly different approach I want to show you toward the end of this problem. So the one thing that is new here is on the left side of our equation, we have 2 that need to actually subtract. We need to combine those together. We need to simplify the left side before we can continue solving. So if I'm doing that, let me get some more room here. If I'm trying to get these to subtract, I need to get a common denominator. So I'm going to multiply like this. So my common denominator will be 2k. So I'll get a 6 over 2k minus k over 2k. So that's going to turn into 6 minus k all over 2k. So this is the point where we could cross multiply and solve. But looking at what we have right now, our denominators are very similar. If I could get the denominator on each side to be exactly the same, then we could simplify this equation. We could just reduce it to setting the numerators equal to one another, right? If I have 2 fractions equal to one another and their denominators are identical, then their numerators must also be identical. They must be equal, which will allow us to solve for the k value that would make that true. So let's go for a common denominator on the right side. Let's multiply this by 2 over 2 so that each side of our equation has the same denominator. So again, if I have two fractions equal to each other and their denominators match, then that means the numerators must also be identical. So we can just take 6 minus k and set it equal to 24. We can subtract our 6. We can divide by -1. And there we have it. All right, that is it for this video. Let me know if you have any questions. We'll get plenty of practice for this. Have a wonderful rest of your day.